Hello, Sauce here. I'm going to talk about solving systems in context. Here I have a problem. It's expressed in words. Many people would call these word problems, but what's important about them is that they have a real-world situation that we need to understand to help solve the problem. This is a contextual problem. I'll read it. Cody bought 6 books for a total of $440. Math books cost $60 and science books cost $80. How many of each type of book did he buy? Contextual problems can be very challenging, and there's not ever one way or one strategy that will work. What we need to do is we need to have some good ideas and some strategies to engage this, and I'll use a couple. The first is I'm going to reread this and I'm going to attempt to understand the context or the real-world situation in my own mind, visualizing what might be happening before I attempt to work with any numbers or equations and solve it. I want to understand what's going on first. So I'm going to reread the problem and then explain it in my own words. Cody bought 6 books for a total of $440. Math books cost $60 and science book costs $80. How many of each type of book did he buy? Okay, in my own words, we have somebody that is buying books, and those books have a price. And there are 2 types of books. The problem is asking us to find out how many of each of those 2 types of books were purchased. So if I understand the situation in my own mind, then I can get to the next step, where the next step is much easier possible, and that is I want to identify variables. I want to choose a letter to represent the unknowns in this problem that lead me to the answer. So if I understand that books are being bought and we need to know how many of each type of book is bought, then I'm going to choose 2 variables, one to represent the number of math books and one to represent the number of science books that are bought, and make a record of that work. I'm going to choose M to be equal to number of math books. This has nothing to do with their cost and price. I'm going slow. I'm not caring about the cost and price yet. And I'm going to choose S, not a 5. And S is a variable to stand for the number of science books that were purchased. Now that I have choices for the variables, I might be able to immediately see that answering the question, how many books did he buy, is going to be the sum of these 2 variables. That enables me to write an equation. The number of math books purchased plus the number of science books purchased is going to be equal to the total number that were bought, but we don't know how many of them were math and how many of them were science books, because that's what we're trying to find out. But at least we have this simple equation. Now, I can't solve this equation because there are 2 unknowns. I don't have yet enough information to find M or S. Now it's time to think about the costs of these books. The 6 books have a total cost of $440. That means that if I added together how much the math books cost and how much the science books cost, then I'm going to get a total cost of $440. How do I add that together? The cost of the math books and the science books is not the same as just those variables. M stands for the number of math books purchased. But to find the cost of all the math books, I have to multiply the number of math books times the cost of each one, which the problem tells me is $60. And if I'm going to add to that the cost of all the science books, I need to multiply the number of science books purchased, S, times the price of each book, $80. Now I've created an equation where the cost of all the math books plus the cost of all the science books is equal to $440, which is what the problem told me. Now look at what I've generated. 2 equations, 2 unknowns. What I have here is a system, and I can solve the system by graphing or algebra, as we've learned to do recently. And if I found a number for m and s that make both these equations true, then I will have solved the problem. So let's now use substitution to solve this system. I'm going to use the strategy of substituting one equation into the other, but I'm only going to understand how to do that if one of my equations is solved for one of the variables first. This first equation is not solved for m or s, but I can do a side problem and solve it for either one. I'm going to choose to solve it for s by subtracting m from both sides. And when I do, the m's cancel out here, leaving s on that side. And on the right side, I have 6 minus m. Why did I do that? Because if s is equal to 6 minus m, then I can take the second equation and substitute in for s what s is equal to. Let's do that. I'm going to take the second equation and rewrite it. 60m plus 80, but when I get to s, I'm not going to write s, I'm going to substitute in what s is equal to. 6 minus m, and I'll finish up is equal to 440. This right here is an equation with only m in it. So I can solve for m and find its value. I'll need to do a couple lines of work. Distribute the 80. 6 times 80. You can probably do this in your head. It's okay to use a calculator. 480. 80 distributed to this minus m is minus 80m is equal to 440. Next line of work, I can see that I have 60m and negative 80m. Those are like terms. I can combine them into negative 20m plus 480 is still equal to 440. Next thing I'm going to do is I'm going to subtract 480 from both sides. These will cancel out, leaving negative 20m. 440 minus 480 is negative 40. And the next thing I'm going to do is divide both sides by negative 20. When I do, I get m by itself. And negative 40 divided by negative 20 is 2. I found the value for m. M is the number of math books purchased. Finding s is going to be quite simple. I'm going to take one of the original equations, I'm going to substitute what I found m to be, and rewrite it. Instead of m, I write 2, plus s is equal to 6. Solving for s is as simple as subtracting 2 from both sides, and when I do, I found the value of s. I have 2 math books purchased and 4 science books purchased. But to be complete in answering a contextual question, the answer ought to be in the form of a complete sentence. Cody bought 2 math books and 4 science books.